All right. Hello, hello. So today we are talking about drawing more repeats of tilings. And this comes up because in Advent of Tess, particularly last year, I included tiling diagrams in the downloads for each individual day. So right here, we're looking at day 14, and there's two kind of levels of things to look at with the tiling. There's the shapes themselves, and then this is actually two layers of annotation. The tiling breaks, so these concentric hexagons that are showing what the stopping points are in the pattern, and these symmetry points. So that's telling you how the pattern repeats. There's a twofold symmetry point in this stretched out hexagon that says, okay, everything on one side of that hexagon is also on the opposite side. And then the 3 in the triangle is saying whatever's on one side is also on the other two sides. The 6 in the hexagon, likewise, whatever's on one side is also on the other 5 sides. So that is telling me, okay, this mixed depth hexagon is the same as the one on the opposite side of the central hexagon. So I could copy it over. And if I wanted to do that literally, what I can do is go to my file and say, okay, so right click, open with another application, Inkscape, and I want to import page 3, and let's go ahead and try that out. So if I remember correctly, and computer's thinking for a bit, if I remember correctly, I put those in as images. And so it's going to have a certain resolution. It's not going to be as easy to work with. But what we can do is delete everything else on the page. We can use this geometry. I can even scale it down a little so it fits on the screen. And I can say, okay, if I want to duplicate that, so I did Control D for duplicate and copy it over, that is how it matches up. And you can see I can't get it to snap in because these are images, not vector graphics. So I can go through and continue just carefully lining up, and I can try to get it to scoot over into place. But this is a bit of a slow, painstaking, error accumulating way of doing things. What I would rather do, for me personally, and like this might be the best solution for you, what I would rather do personally is plop it into another file and start drawing the shapes from scratch. So I just clicked on the star/polygon tool. I have it set to 6 sides as the polygon, not the star. And I can outline that, and I'm holding down Control as I do that to lock it into one orientation, and actually Control snaps to like every 15, or it's either 15 or 30 degrees. And I can go in and say, okay, I want the line thickness to be, I think, 0.5 millimeters is fine. And then I can take that and say, okay, what other shapes do I need? Because I can build all of these shapes from a hexagon. I've got the central hexagon. I need a trapezoid, I need a triangle, and I need this stretched out hexagon. So I'm going to bring up my drawing tool. I use the keyboard shortcut Shift F6. And what you want to make sure of is that you've enabled snapping to, at a minimum, path intersections and cusp nodes. We can also, like for this case, it actually would be useful to have object midpoints as well. Because if I can just snap to the object midpoint, then I can build a triangle directly. And actually, I like that line style better. So I'm just copying the line style over to the hexagon. So now I have a triangle. Oh, and by the way, I want all of these shapes to be filled in. So I'm making them filled white. I can also fill them red if I want, but white is good for now. That's so I can grab them from the center instead of just from the edge. And I also need a trapezoid. And I need that stretched out hexagon as well. So I'm going to copy this one and shift it over. See how that's snapping into place? And now I have that stretched out hexagon shape. And I can draw a new one. And each time I'm clicking, rather, these shapes are, or the points are snapping into place. So see how that's overlapping and there's no inside to this shape. Like if I click in the middle, it doesn't click the shape. So I need to make that white on the inside as well. And yeah, also the trapezoid. So then if I want to copy the colors, let's see, do I have a color picker option for my fill? Let's see. Aha, I can pick colors from image. I'm going to pick that one. And then for the triangle, I'm going to pick that color. For the trapezoid, I'll pick that color. For this hexagon, I'll pick that color. Bingo, we're in business. And one other thing to notice, there is another triangle. So I can duplicate these central triangles and make those that color. So that's how I can quickly go from an image to the same thing in vector graphics. Very convenient to do. And let's see, this will probably show the stream chat for a little bit. Oh no, I already moved it to the other screen. Excellent. Yeah, feel free to ask questions, by the way. So if I want to go and get this image back based on what I have, I can take my triangle, and this is a good point to turn off snap to center, snap to object midpoints. We just want the path intersections and the cusp nodes. It gives the computer less to think about. And then I'm looking in the image for what orientation of trapezoid goes next to that particular triangle and getting that slotted in. I can stick my hexagon on top and that triangle on top of there, and I can now move the image out of the way a bit and duplicate, and I'm going to do this rotate by half twice, or sorry, rotate 90 degrees twice, which takes it to the other side. Then I can select everything, deselect the center, duplicate, so that's keyboard shortcut Control D, and then I want to go in my transform menu, which if you don't have it up, you can do Shift Control M. I think the shortcut that I typically use, like all these menus that I typically use, if you type Control Shift and hold those and then FLAME, flame, you'll get all the menus I usually use. So then I want to rotate by 60 degrees, duplicate again, rotate again, and that gets me back to my original image in a form that will snap together. So I can get rid of that original image, and I can choose to do the thing that I mentioned earlier, and I would want to group everything before duplicating and copying over, and now it snaps into place. So that is one option. The other option is to, so going back to the ungrouped form, to separate out precisely what's needed to fit together without overlapping. And there's a shortcut to be able to remember that for the different symmetry types. This is hexagonal symmetry. We saw the position of six-fold symmetry in the center. And so we're going to need all 6 orientations of things that are asymmetric. So our trapezoid and our central triangle, or our more central triangle. We need 3 different orientations of the things that are twofold rotationally symmetric, so we can get rid of 3 of the mixed depth hexagons. And we need 2 orientations of the things that are threefold rotationally symmetric. So one way to remember this is twofold symmetry, 3 orientations, 2 and 3, multiply them together, you get 6. Threefold symmetry, 2 orientations, 3 times 2, multiply them together, you get 6. So I can get rid of these duplicates functionally of these 2 triangles, and then group everything together, duplicate, and now when I snap in, it's right next to my original shape, and I can make this as big as I want. So I can just take stripes of this and then copy the stripes over and really fill up as much space as I'm interested in. Like starting, okay, and it'll keep snapping if my computer doesn't get overloaded. So this is enough of the tiling for most of the patterns that use it to easily cover like 80, 144 divisions of grid, like starting here in the center and getting out past these repeats. That's going to take you at least 64 divisions in most cases. And so this is a much better thing to be working from than just that small repeat. And then you can start seeing, okay, and I'm going to draw these in. Okay, I've got the break that we had originally, and snap, there we go. And I'm gonna make this, actually I can, well, there we go. And I can make it a different color if I want, like, no. If I just click it, it makes the center that color. That's not fun. Maroon is better for this color scheme. And there is one more true tiling break, which is out here. Snap for me, there we go. So you can see that next true break but there's no true break after that. The maximum length of straight lines in the pattern is this length. The lines just can't go any further in the pattern. So you're going to be dealing with some form of pleat overlaps, probably at the corners. What I would do is probably, yeah, in this case, it's really in the corner, so it's hard to figure out exactly where you're going with it. And you can turn on snap to paths, which will help here. So I think that this is the next good break, and I'm using the control command to keep my angles in line here. So that's probably the next break that I would do. It gets you through this whole mixed depth hexagon. It means you don't have to stop halfway through a horizontal mixed depth hexagon. You will have pleat overlaps in here, and probably the best way to deal with that is two pleats coming out this way and another pleat crossing them. You're just going to have the overlaps. And that's probably about as good as it gets. At this point, I'm usually reaching the end of the pattern, or the end of what I want to fold, because I have all 6 of these mixed depth hexagons around the repeats of the center. But that's kind of what I would think about for those patterns. And then the other kind of pattern that we have in Advent of Tess is patterns with only 3-fold symmetry. So, for example, day 11, pivot blocks, flagstone cubes on both sides. We've got this structure where we have 3-fold rotational symmetry in 3 distinct positions. And the way those patterns work is you need each of those 3-fold positions, and each one only ever appears in one orientation. So we can go ahead and open this page in Inkscape. And We'll open a new file. Bingo. So now we have this image, and I'm going to go ahead and copy it over to this file, just so we can be working in the same area. Move this up to the corner. And for this one, we need rhombi and triangles. So once I have a set of shapes, and I'll just borrow this one down here, I can keep using that set of shapes to construct more shapes. So I'll ungroup, and now I already have two distinct triangles, which we can check. I'm going to bring them to the front so we can see them in front of these guys. Yeah, that's the same color, and that's the same color. Excellent. But we do need to mirror this one top to bottom, or we could rotate it 60 degrees. It's the same operation. This time we do need rhombi, and so I'm going to bring back our snapping to object midpoints and get those rhombi out of the hexagon. And I'm going to temporarily make it that color just to get the styling right. And then we can do our color picker thing with the fill color picker. Let's make it this one. And then we'll duplicate and pick the other color for the other rhombus. So now I'm going to start putting these rhombi around their respective triangles, and I'm seeing that these guys meet up, and what I'm going for is all three orientations of rhombi around these triangles. And I'm just paying attention to the pattern. What I'm going for is the 3 rhombi around the pale triangle and the 3 rhombi around the darker triangle. And those are the 2 chunks that make up the whole pattern, which I'll show here. So we don't need the rest of the pattern anymore. We can take these 2 chunks, group them, and duplicate, and make sure to put them together so that the lighter shapes are touching the darker shapes. And again, put them together in a stripe first. I mean, not necessary, but really convenient if you want to do what I'm doing now and put together whole stripes instead of each one individually. Let's add a little more up here. And you've got that pattern appearing in a bigger format. And I can go ahead and add even more if I want. snap for me. Sometimes changing the zoom will help it snap. Oh, also reducing the amount of things it's trying to calculate. So that is how I would think about building out patterns with threefold rotational symmetry. You want to have, and in particular with this tiling, since one of those positions of threefold rotational symmetry is outside of a twist, I want to make sure I have two of the things around that position, and I have those two things in all three orientations. And then the threefold symmetry points inside of the triangles, we can build out as well. I do want to say there is another arrangement of these same shapes that also works to generate the full pattern. So it's not strictly one way to do things. Like I can take these twists and just rearrange them not duplicate, and just move them. So this is another completely valid way to generate the whole tiling. And it's probably easier to snap in the right way. At least for my brain, it's a little easier. And then you get things very focused around the center, as opposed to what I was doing before, which was less, or more, a little more chaotic. And so here I'm choosing to decrease the number of repeats in the stripe as I go further out, and I can very straightforwardly make a pretty hexagonal representation of what I'm going for. So that's convenient, and then you can superimpose the concentric hexagons and get all of that to work out. So there's usually multiple ways to get things to work out. With the threefold symmetry patterns, it's even more clear that it's multiple ways. With the hexagonal symmetry patterns, you really do want kind of that mushroom shape where you have whatever's around the sixfold core and all the asymmetric positions, and then 3 of the twofold positions, 2 of the threefold positions. Of course, there are examples where you do not have the twofold and threefold positions inside of twists, in which case you don't really worry about those positions at all. You just take care of the 6 orientations of anything asymmetric. Really, what you need is 1 orientation of the sixfold symmetry point, 6 orientations of anything asymmetric, 3 orientations of anything twofold, 2 orientations of anything in a threefold symmetry position. And if those positions are outside of twists, then you don't need to worry about it. So that's how I would draw more repeats of these tilings. And then you can, of course, go and add layers of, okay, where are the symmetries? What is the skeleton? Are there other colorings that I'm interested in? What are the boundaries for the tiling breaks? And building things out from there. So this is a very practical question when it comes to figuring out okay, I want to print something out for a bigger project to guide me through what twists to add when and where. And when you are able to draw whatever amount of the pattern that you want, that becomes a lot easier. And I'm not seeing questions in the chat. One other thing that I want to show is my system for creating the tiling diagrams that I use in Tessellation Academy. And I actually have a template file, which Inkscape will eventually let me bring up, for documenting a tiling. And I have different things already saved in each of the layers. So the first layer is the base. These are the shapes. And I already have the hexagon, triangle, rhombus, trapezoid, also square, right triangle, square on the diagonal. These are my common building blocks. If I need a mixed depth hexagon or a mixed depth rhombus, I'll construct that from one of these. And once I have the base in place, then I go to the skeleton layer. I have the line style saved. I can just copy that and then paste style for my skeletons. The symmetry layer, I already have all of the points in different colors and a mirror symmetry line, and yeah, all of my different options. And the boundaries, I already have the line style that I like to use for the boundaries in there. And of course, any additional boundaries. I also have a mask layer that basically is the border of the page. And so I can copy these repeats out and I don't have to worry about trimming each individual shape that pokes over the edge. I'll just clip it with the mask layer like I do my crease patterns. So that is some of the infrastructure that I've built up for myself, and like the layers that I see as interesting when I'm talking about these bigger tilings. So that could be something that you build for yourself, and you get to decide. Well, the one layer I didn't mention here is this veil. That is a fixed layer. I'm going to bring in these squares. So the veil is just a white semi-transparent layer. It makes the colors more muted. It lets you focus on other things. And yeah, that is all the layers of my template file for making tiling diagrams. And that covers the hexagonal and triangular symmetry things, which is what you'll find in Advent of Tess. For the square symmetry things, and again, these are the same rules that I talked about in previous streams, which you can find in my symmetries playlist. For square things, square symmetry things, you have 2 positions of 4-fold rotational symmetry and 1 position of 2-fold rotational symmetry. So actually, we'll just look at an example. I'm going to go to my tilings. And by the way, I have a bunch of full diagrams of tilings that are in Tessellation Academy or will be soon. And there's still quite a few that, or at least several in Advent of Tess that are not in this list. So for this example, I'm going to make this layer editable. The chunk that I'm working with, select out one chunk. The chunk that I'm working with has 2 positions of 4-fold symmetry and then 2 different orientations of the position of 2-fold symmetry. So I've got the 4-fold, and actually I can bring up the symmetries. You can just look directly at this chunk that's missing. I've got the 4-fold symmetry position in here, and the 2-fold position to the right of it is going to be in a different orientation than the 2-fold position above. So you need both of those orientations, but you don't need the ones on the other sides because those are going to be the same as the ones directly opposite them. And you can see the darker and lighter tiles showing up in the same orientation over here as they do over here. So I needed the 4-fold position, all 4 orientations of the asymmetric twist, second 4-fold positions, all 4 positions of the asymmetric twist around that, and 2 different orientations of this loop of 4 twists, each one of which is not in a symmetry position, but the 4 of them together make up the 2-fold symmetry position. And so that is how I would use the symmetries to determine how to draw something in the square tiling. And that pretty much covers it. There are some tilings with lower symmetry, like parallelogram symmetry, but often those are stripes, and you find the smallest bit that repeats in the stripe and then build out the whole stripe and just copy the stripe over. Yeah. So that's what's going on with drawing things, with drawing tilings with more repeats. And I'm still not seeing any questions, so I'll take it that that was a reasonable explanation. So happy folding, everyone. I hope you are able to use these tiling diagrams to fold bigger and bigger patterns, more repeats of these Advent of Tess patterns and the other patterns that I publish. And I will see you next week. And I will at a minimum be folding something, probably a tutorial. I don't remember specifically which one. Could look it up. But yeah, so happy folding, everyone, and I'll see you there.